All right, we're going to jump right in today with a massive question, one that kind of messes with your head. What if time itself isn't real? We're going to explore a theoretical model that challenges, well, pretty much everything you think you know about how time works. So let's get into it.
We all feel it, right? Time is this fundamental river we're all floating down. It's the T in space-time. But what if that feeling is wrong? What if time isn't a dimension at all, but something else that just emerges? That one question is the key to this whole explainer.
Now, before we can even think about breaking the rules, we gotta know what the rules are. And for the last 100 years or so, the rulebook for the universe has been written by one guy, Albert Einstein.
Einstein's special relativity gave us this absolutely wild idea. The faster you move through space, the slower you move through time. I'm serious. An astronaut on a super fast ship literally ages less than their twin who stayed on Earth. So time isn't this universal ticking clock. It's personal. It's relative to how you're moving.
Then he dropped another bombshell with general relativity. He said gravity isn't some invisible force pulling things together. Nope. Instead, really massive things like the sun actually bend and warp the very fabric of reality around them. And everything else, even a beam of light, is just following those curves. So the takeaway from Einstein's world is that reality is this giant four-dimensional map called spacetime. Gravity is simply the shape, the geometry of that map. It's a beautiful, powerful description. But, and this is a huge but, it leaves one massive question just hanging there.
And that brings us to the mystery that Einstein himself spent years struggling with. He described the geometry of spacetime perfectly, but he couldn't explain why it has that geometry. What's the reason behind the rules?
You've probably heard this quote. Einstein really disliked the randomness that quantum mechanics suggested about the universe. He was convinced that underneath all the weird effects of relativity and quantum probabilities, there just had to be a deeper, physical, predictable reality. An engine driving the whole machine. And this is the core of the puzzle. If gravity is just the shape of spacetime, what's physically doing the shaping? If a moving clock slows down, what physical mechanism is actually making its gears turn more slowly? See, Einstein gave us a perfect map of reality, but he couldn't find the engine that made it all run. So what could that engine possibly be? Well, let's look at a potential answer, a model called the harmonic scale framework, or HSF. It suggests that the fundamental engine of reality isn't made of particles or points, it's made of waves.
Okay, so what does that even mean? In the HSF model, the universe isn't made of tiny billiard balls. Instead, picture it more like a giant, cosmic guitar string. An electron isn't a thing, it's a stable, vibrating note on that string, a resonance. Everything, you, me, a distant star, is just an incredibly complex chord being played by these fundamental waves.
Okay, now here is the central idea that changes everything. In HSF, time is not a dimension. Let that sink in. Time is phase. So what's phase? Imagine a wave going up and down. Phase is just a measurement of where you are in that cycle, at the peak, in the trough, or somewhere in the middle. That's it. I'm going to say it again. Time is simply phase.
So what does this mean for us? It means your personal experience of time is just the rhythm of your own internal waves. Think of it like a metronome ticking away inside of you. Every tick is one full cycle of a wave, one complete change in phase. A faster rhythm means time feels like it's passing faster for you. There is no single universal clock for everyone. We each have our own internal metronome.
This is where it gets really interesting. I mean, if this wave-based idea is true, it can't just be a neat concept, it has to be able to reproduce the proven, weird effects of Einstein's relativity. And according to this framework, it absolutely does.
And this shows the difference perfectly. Einstein says if you move fast, the actual coordinate of time slows down for you. But HSF says no. When you move fast, the carrier wave that makes you just oscillates at a lower frequency. A slower oscillation means a slower accumulation of phase, which means your local clock, your internal metronome, ticks slower. You get the same result, but it comes from a physical mechanism, not just a rule about geometry.
It's the same exact story for gravity. Einstein says mass curves geometry. HSF proposes that mass doesn't bend space, it distorts a deep underlying wave field. Kind of like dropping a bowling ball on a trampoline. This distortion creates a slope, a phase gradient, and other objects are just rolling down that slope. The map's curve is really just the slope created by the engine's distortion.
This table really puts it all together. You can see that for every geometric concept in Einstein's theory, HSF gives us a physical wave mechanism. Time, the speed of light, gravity. In HSF, they all emerge from the behavior of these waves. The results we observe are the same, but the cause is totally different. HSF isn't trying to replace Einstein's map, it's proposing the engine that makes the map look the way it does.
And this brings us all the way back to Einstein's dream. If reality is fundamentally based on the predictable behavior of waves, it could mean the universe isn't random after all. This framework offers a potential path to the reality he's searched for his entire life, a world without dice. This right here is the single most important takeaway. Einstein's relativity is a perfect predictive map of reality. It tells us how things behave. HSF is a proposal for the physical engine that is causing that behavior. It's the physics behind the geometry.
By doing this, HSF gives us a deterministic cause for all of relativity's strange effects. It suggests spacetime curvature is just a change in a background wave phase. It unifies time, mass, and energy as different expressions of wave frequency, and it derives relativity from physical principles, rather than just starting with assumptions. It paints a picture of a universe that is fundamentally orderly and predictable, just like Einstein always hoped it was.
And so, we're left with this question. Is reality a vast geometric clockwork with time as one of its fundamental gears? Or is it more like a grand cosmic symphony, where everything, including our own experience of time, is just a local rhythm in a universe of waves? The harmonic scale framework suggests it just might be the latter.